put my students on the spot who had me all year. Okay, you guys, we are going to solve differential equations today. We don't know what a differential equation is, but we need to know what solve means. Oh, the assignment sheet? Yeah, but I'm not going to give it out today because I'm going to give you an assignment that's not on the assignment sheet. Then tomorrow we'll be starting to solve fields. Okay. Declan, do you remember what it means to solve? That's the process. Let me give you an example. And I know that some of you are going to say, why are you doing this? Because we're going to solve differential equations. Do you know what solve means? You can solve anything. I'm going to unteach some of the things you were taught because you memorize how to do the process, but you don't really know what you're doing. So if I know what solve means, then this is great. I don't have to know the process because by inspection, I can tell you what x is. I'm going to tell you x is 3. Now, Jack, did I solve that correctly? Jack should know the answer to this question. What does it mean to solve? Well, how do you know if it's correct? How do you know that that's not the right answer, Zach? Casey, what'd you say? This statement here is not true. He's listened, I guess, in the past. This is good. Solve means to find, yeah, but let me show you how powerful this is. Number that makes a sentence true. Here's the problem. When we solve guys, if you want your test back, you have to be quiet. When we solve differential equations, they will say, Jack, solve this differential equation. If you don't know what a differential equation is, how are you going to solve it? Yes. Okay, find the number or numbers that make the sentence true. Now, there's nothing wrong with inspection. I can inspect that. I can look at it and say, oh, whoops, it should have been what? 4. Okay. But then we get into complicated things, and then I have to learn a process of trying to isolate x. And really, honestly, if you're talking about solving here, this equation, x plus 3 equals 7, is not the same as x equals 4. This I can look at and say 4 makes that true. So there's no problem with that either. I can look at 4 and see if 4 makes that true as well. Well, let's extend this a little further. Let's take this. Actually, I'm going to do this backwards. Let's say 3 is less than x. Now, I teach algebra 1, and we get to inequalities. I do not teach them about arrows pointing different ways. You know, what they do is this. They say, oh, 3 is less than x, and they do that. Did they do it correctly? No, didn't do it correctly because if you take 2 or 0, 3 is less than 2, that's not a true statement. So instead, and I've done this all the way through calculus, and I'm going to do all the problems this way, I'm going to use the boundary method with zeros or with true statements. So I'm going to undo this. I'm going to erase this right here. And I am just going to take 3. That's my boundary. Now, either the right side makes it true or the left side makes it true. So what's the easiest number I can substitute into this inequality? 0. Is 3 less than 0? No. So therefore, it goes the other way. Now, what if I have this one? Negative 3x is greater than or equal to negative 9. Now, what do you have to remember to solve this one? Okay, but students who aren't as strong in math as you are, you guys are very strong in math. I want you to remember that. You are. They divide by negative 3, and they can't remember adding negative 3, dividing by negative 3. They don't remember what switches the sign, because that's a memorization. Okay, so instead, if I divide double sides by negative 3, this switches. Negative 9 divided by negative 3 is 3. Let's find out. Let's find out. Let's pretend it's this. Let's find a boundary, because one side or the other will be true. Well, first, let's just solve that. Where's the boundary? 3, right? Okay. Now, let's go back to this, and let's just plug in 0. Negative 3 times, I don't have to remember this thing about dividing by negatives. That's one more thing I have to remember. I got too much stuff to remember. This is easier. Is 0 bigger than negative 9? Yes. Okay, so it's this, guys, and 0 makes it true. Jack. I don't have to remember that. And you say, well, so what? That's still easy. Well, it's not so easy when I get this. That's an absolute value inequality. Juniors, you have to pass the MCA. Yes, you do. Then why doesn't everybody pass? Yes, you're very good at math. That's not easy. Okay, shh. You guys? Guys, do you want your test back today? Okay, let's quiet down then. Okay, Zach, this is an 8th grade standard. You're expected to be able to solve this inequality coming out of 8th grade. Now, I don't know how you were taught, but I was taught, and I used to teach it this way. 2x minus 5 is greater than 3. Greater, so it's an or. 2x minus 5 is less than negative 3. Did you learn that? And that's hard. Good, I hope it's no. That's a good thing. That's correct. But it's easier to just do this. 2x, let's pretend it's equal to 3. I'm going to find the boundaries. So now I know what solve means. Some people will forget what to do with that. Now what does solve mean? Put numbers in there, make that true. What makes that true? 3 makes it true, so whatever's in there makes it true. Now, except for the linear equations, we always compare it to 0. So then 2x equals 8. X equals 4. Guess what the other mistake is? Somebody's going to say negative 4. Not going to happen. It's rarely going to happen. It's only going to happen if you don't have that 5 there. So when you add 5 here, but those are mistakes that can occur on the MCAs. So x equals 1. Okay, I'm just going to straighten the line a little bit. I am going to put my boundaries here, 1 and 4. Okay, you guys? Do I get to include them? No. All 3 regions could make it true. 1 region can make it true. 2 regions can make it true. All you got to do is put points in. So what's a nice number between 1 and 4? You can try on that. We can do 0. 2 times 0 minus 5. Is that bigger than 3? Absolute value of that. What's the absolute value? What's the absolute value of negative 5? 5. Is 5 bigger than 3? So 0 works. I'm not doing any fancy stuff with ands and ors. I'm not solving any inequalities. I don't have to worry about what happens when you divide by negative. That's a hard problem to do. This is much easier. Just test the region. What number you want to try here? 2? 2 times 2 minus 5. Nope, doesn't work. And let's not go with 5. Let's go with 100. 2 times 100. Is that bigger than 3? And then you make a statement about what makes it true. So what happens when you get this? Yes, you could end up with algebra like this. Okay, you might end up with something that looks like that. I can tell you the exact example of what looks like that. I won't do the prep, I'll do a different one. Okay, that's a less than, so it's an and I have to split it up into 2, and then I have to worry. When I do this, now, can you guys multiply by x? Is that allowed? No. Even if you add 3, you still can't multiply by x, but why? X could be positive or x could be, then you have to break it into cases. I don't want to do that. That's a lot of work. And there are other tricks. But my trick is the easiest. Forget that. Pretend it's this. 1 over x minus 3 is less than 2. Find what x is. Find the boundary points. So 1 over x minus 3 equals 2, or 1 over x minus 3 equals negative 2. So x equals, 1 over x equals 5. So x equals what? 1/5. And if I add 3 here, 1 over x is equal to 1. So x is equal to 1. And there's another boundary point. There's 3 of them. Because where do boundaries occur? They occur at the zeros, but where else? Undefined. when you have a vertical asymptote. I got a boundary when x is what? Okay, Steve? When x is 0, I got a boundary. This is important because this is the foundation of solving. Once you know this, you can solve a differential equation because it's the same thing. Okay? So you got to put in 0, and then what are you going to do? This one definitely can't work. Can I have equals on this? No. So none of them work. And you just test each one of the little regions and find out where it's true. Could be more than one region. Might only be one region. So that's the problem. So let's do one more like this. I've seen this on the exam. And honestly, I see this all the time. Oh, yes. Expect ln and expect e to the x. Why? It's just a log. Just a log. It's a natural log. Why doesn't it make sense? Where does it come from?
An exponent. Logs are exponents.
Right. E to the x.
That's all I know this trick.
It's the inverse of e to the x. It's an inverse. If I take the log of e to the x, they undo. If I put x into this function, I get e to the x. I put that down into the log function, it undoes the exponential process, and I get x. That's what inverses do. That's why we have problems with the second fundamental theorem of calculus.
Where does E come from though? It's not like pi where it's like the circle.
No, it comes from some other. It comes from these other things. Well, after the exam, how about we do that? Okay. The other thing about after the exam that might be nice, you guys, Declan, is to maybe do some programming on your calculators because you don't know anything about programming, and you should all know a little something. Okay, you guys, the question is find the domain. This was right off an AP exam. What is the domain of that? Yeah. What has to be true about the input here? What has to be true about the input for a log function? It's got to be what? That's right. How are you going to solve that one? You can't multiply by x minus 1. Well, that's wrong. That's the problem. You can't. So you could multiply by x minus 1 squared, but it's easier than that. I only have 2 boundary points. First one, how would you compare it to 0? What's the first point? Whoops. Well, don't say greater than 0. I just want the boundary point. I pretend it's equal. Where's the other boundary point? Not negative 1. Close. Positive 1. And all you do, now, it's greater than 0, so guess what? I can't include either one of those. And all you do is test your regions. Now, any function, except for linear ones, you always compare to 0. If you can remember that, that's going to help. Always, to solve any function, you have to compare it to 0. You always look for the zeros. Okay, so let's put in 100. Is that positive or negative? Jacob, was that positive or negative if I put 100 in? Okay, that's horizontal asymptote. Besides, do you want to try the 1/2? It's not that hard. 1/2 and then 1/2 minus 1. That's negative. And what about, and don't assume this is negative over here, what about negative 10? Negative 10 over negative 11 is, there it is. That's my answer. Well, when my students do this in BC Calc, you'll see this question in BC Calc. Guaranteed. Hey, guys, they won't give me this piece. What they do is this. Hey, guys, can you not talk? Hey, guys, later. Jack, I don't care. This is what they do. They say x is positive, x minus 1 is positive. That's true, but that's not all. What if x is negative? X minus 1 is negative. How are you going to solve that? That is not easy. Just do the boundaries. Boundary method always works mathematically solid. Yes. Because I can't divide by 0. That's your other boundary. So if you know what solve means, then life is good. So that's what solve means. Find numbers that make the sentence true. That's all it is. Guess and check is okay. It wasn't okay on your test because I'm looking for something else besides that. On the real exam, yes, if you have to do guess and check. Keep in mind, though, it is a timed test. So guess and check takes longer. You get about a minute per problem. But some are done in 2 seconds. So then you can add your minutes up that way. But we'll do a practice test before the exam. We'll actually take some class time to do it. I'd rather go over review, but the problem is that's a problem. Okay, are we ready now? I did all this. That's on the other page. Oh, no, I have to teach. That was just what solve means. Now let's do section 6.1. Oh, we got to get what, if you know what solve means, life is good. Guess what? I'm going to bug you every day. Now, guys, knowing what a differential equation is? Well, I could. I put Schoology. Okay. Now, you should be. You should be, because then you wouldn't have forgotten about the test. Okay, shh. We told you the week before. We had to, because there are too many interruptions. Okay. You guys, you have to know what a differential equation is. Guys, there's a test question. There is a test question on this. What is a differential equation? Knowing the definition. How many should get this right? Everyone. How many will get it right? 75%. Okay, let's not do the one. Okay. A differential equation is an equation involving a derivative. So you're going to see a derivative in it, and whose solution is a function. This is right out of the book, but I want you to know this. I'll read the rest too. But that's what we're talking about. We are not solving and getting numbers. We are getting functions. We're getting equations. Now, the order of a differential equation is the order of the highest derivative. So if it's dy dx, that is a first order, and that's all you'll have to know. You will not be doing a second order. Yeah, that is, of course, all by itself. And we don't say differential equations. We call it diff-EQ. And here's the other thing. I'm 99% going to guarantee, not 100, because I think sometimes they've not had diff-EQs. But you're going to have a differential equation on the exam. Easiest 9 points you can get. Okay? Okay, so here I have, and I'm going to teach this correctly, the proper notation. It gets us ready for doing differential equations in 6.4. That, by the way, is a short chapter. 7 is a short chapter, and we're done. We're done before spring break. Woo! Even taking it slowly, we're done. Okay, so we're getting there. Okay, guys, Jack, I want to solve this differential equation. Here is my derivative. Guys, if you just pay attention, it's a lot easier. I'm trying to find a function that if I take the derivative of it, I get this answer here. Jack, do I need to move you? Okay, so first I'm going to recopy it because I want to work with it. The question in the other class, which is a really good question, is that really mean this? No, not unless you have the parentheses there to begin with. And I can't do the problem either then. So unless you have parentheses around all that with the pluses, no, they're separate functions. Now what I'm going to do, and some people say, can't we just integrate it now? Because what if I integrate a derivative? I get the function back, right? Well, I want to do this properly. These are easy ones today. We're going to multiply through by dx on both sides. That's how we're going to be doing a differential equation. So let's just do this the right way to begin with. It's secant squared of x plus 2x. We did this a long time ago when we did differentials. I was your teacher. I know I did differentials.
Where do you like distribute it now?
I'm not going to well, I could. Now, how do you get rid of a dy? You integrate it. Can't solve it. And what's the antiderivative of 1 with respect to y? I won't. With respect to y, it's y. If I had a z here, it would be a z. These differentials are important. On the exam, on your free response questions, they will not mark off if you forget the differentials. However, when you get to the next chapter, you see why you really want the differentials there because they really help. Because that's a good question. This symbol says find the antiderivative, and this symbol says the variable is going to be y. Because there's a number there, it's not 0. If you had 0, you'd have to see 0. You wouldn't even see anything. So what's the integral of dx? What's the antiderivative of this? That's just x. The derivative of x is 1. The 1 is there, we just don't write it. I put it in there to make you see it better. But it's there. This tells you the variable in question. So if I see the dx there, I know my variable is going to be x. And this says find the antiderivative of 1. So the derivative of what function gives you 1? X. Okay. As far as you're concerned, you're just going to integrate the right side. So we're going to get into more complicated things. Now, what is antiderivative of secant squared? Good. That's very good. What's the antiderivative of 2x? 2x to the second, what else? Divided by 2. How do you know it's right? Take the derivative. Derivative of tangent secant squared. This is going to cancel with the 2's. The derivative of x squared is 2x. That's right. Plus 5 times what? If you leave it 5, what's the derivative of 5? 0. Is it 5x squared or just 5x?
5x.
Plus c. This is called a general solution. Oh, you were just ahead of me. Now, on the exam, okay, Samuel?
Yes.
On the exam, you will be given a tougher differential equation. Okay, guys, guarantee you will have a differential equation. You will get a point for, in this case, probably a couple points for finding the antiderivative since there were so many. You get a point for adding c at the right time. If you do it late in the problem, you don't get your points. Usually a 5 or 6 point problem. So easy points to get, actually. Yeah. What happens to what? This symbol, this says my variable is with an x. Because I could have done 2y dx. That's left to multivariable calculus, sophomore level course in college. I don't even want to go there. So this just tells you the variable. I could actually pull the 2y out. Well, that's y is a function of x, but I don't know. This tells you the variable. This symbol with this says find the antiderivative of that, but with respect to x. So we don't know multivariable calculus, so we better not do that one. They will always match. And it gets used up like a square root symbol. So when you do this, these are good questions. F of x dx, it means find the antiderivative of that thing. This together with this. Like, you don't question me on this, the square root of 9. What is that? Not the square root of 3. That symbol told you find the number that multiplies by itself to give you 9. This symbol, no, this symbol means find the antiderivative of that with respect to x. Always with respect to. Because what if I have y equals x squared, and I take the derivative with respect to time? That makes a difference. Remember that for related rates? So I get dy dt. What's the derivative of x squared with respect to x? It's 2x. Then you have to do the derivative of the inside function, dx dy. T. No, I did my derivative was with respect to t. So if we don't get that, then that's why this doesn't make sense. Now, geometrically, it makes even more sense. This is the base of your rectangle. That's delta x. And this is the height of your rectangles. So I do put the geometry in. It all goes together. And it turns out that if you have limits of integration here, it's the antiderivative evaluated at b minus the antiderivative evaluated at a. Y is an antiderivative equal to an area. It doesn't make sense, but right now you have to believe me. After the exam, I'll prove it to you why it is. But it'll take probably an hour to do it. It's not an easy proof. Okay. Somebody got a text. Yes. Yes. You have to do it right after you integrate. Let's do another problem. Okay. There it is. Sometimes we have problems with initial conditions. It's called an initial value problem. Now, you will see those words on the exam. If you don't know what they mean, how can you do the problem? You can't. Okay, we're going to find particular solutions. That was a general one. Okay, so let's do this one. So this one's going to require some more. And I'm going to explain to you how it gets graded. We have to start preparing for the exam now. But wait till April's too late. So first thing I'm going to do, and you're right. Some of you are going to say, can't I just integrate the right side? Yes, you may do that. I'm not going to mark it wrong because it's not wrong. But later on, we're going to put y's over here and x's over here, and you're going to have to figure out what to do with them. So this is the first step. We clear out those fractions and we put it in differential form. Yeah, someone's calling somebody. Is it an iPhone?
Oh, look who it is. Jacob Nelson.
Oh, it's he's calling. That's a good question. Okay, guys, we got to get through this. Jack, multiply by dx. You should be doing this with me. Do this with me. So dy equals e to the, just watching is not going to work. As some of you are finding out. Math just gets harder. Gets really a lot harder in college. So get your good work habits here. Now we're going to integrate this side. What letter will be there? Y. No, it's just the text. Okay, equals. Okay, that's e to the x. It looks kind of messy. What's the antiderivative of e to the x? Because it's on the ledge. What's the antiderivative of e to the x? E to the x. Now, you guys get better at this by practicing. You didn't learn how to multiply by not doing multiplication tables. It's the same thing. So it's minus 6x what? Go up by 1, Declan, cubed over 3. Now, you must put the c in right now. Now, there's a c on both sides, but we're just going to put all those constants on the right side. Because they're arbitrary, so who cares? They don't matter. If you put the c in later, then you're going to be in trouble. We have an initial condition. It goes through 1, 0. Now, you get a point. We've now earned a point, maybe 2 points, one for this, one for that, one for adding the c at the right time. If you don't add it at the right time, you're ineligible for future points. Yes. But this I can teach you. You just have to, especially those of you who like to memorize, this one you got. Okay? This is x and this is y. Guess what? You get a point for putting this point in the right place. So what's the y value? 0. 0 equals, then x is e to the first minus, let's go ahead and simplify, 2, 1 cubed plus c. You get another point there, and you get your final point for finding out what the function is with the correct c value in there. What's c equal to? Jack, what's c equal to? No. If you put this on the other side, it becomes negative. And then your final answer is this. Now, this was an easy one, by the way, compared to what you're going to see on the exam. Because how do you integrate? I took 6x squared. I left the 6 alone, and I made this go x cubed divided by 3.
Why is that equal that?
It's a negative. Check. How do you know if I did it right? Guys, how do I know if this is right? Take the derivative. What's the derivative? Y prime equals e to the x minus 6x squared. And what's the derivative of this guy? The constant. 0. Right. Okay. Another problem. Ready? Now, forget that discontinuity thing. We're not going to worry about that. We're just going to do the problem. So let's just do another problem. So dy, let's multiply through by dx because that's the correct way to do it. And it'll come back. We'll do it again that way. So I don't want to confuse you. We'll just do it right from the beginning. Okay, so multiply by dx. Now what do we do? Noah? Take the antiderivative. You guys will get your chance to teach later on. Class. When we do the practice problems, I'll teach us. What's this antiderivative? That's y. What's the antiderivative of 2x? X squared. What's the antiderivative of secant squared? Tangent. Now what must I put in? Plus c. Did I play the Bohemian Rhapsody in here? Don't you remember the plus c? You better come to class more often. Now we got to find out c. What? Why? If it's 2x squared, what's the derivative of that? That's 4x, right? Do I have 4x? How do you know you did it right? Take the derivative. Now, put this in, but please put the numbers in the right place. If you put the numbers in the wrong place, you don't get the point. So you're doing 1, 2, 3, 4 points, and the 5th point is for finding c correctly, evaluating it correctly. How easy can you get? So 3 equals 0 squared. If you don't know the tangent of 0 on the free response, leave it the tangent of 0. It is 0. I want to know that you know that. Okay? So what's c equal to? C is equal to 3, so my answer is, I'll change colors, y equals x squared minus the tangent of x plus 3. You should always check when you solve a differential equation. There. Okay, guys? Check. You should always check your differential equations. Like when you factor a trinomial, you should always multiply it back out, see if you did it right. I can't get my algebra kids to do that. Oh, I know I did it right. Well, no, you didn't do it right. That's the problem. Now, why are there 2 stars on this next problem?
Test question.
It's on the AP exam. Okay, I'm going to use the fundamental theorem of calculus. So you'll figure out what's going to happen here if you want to. Well, I like the fundamental theorem of calculus because what I'm going to do is integrate f prime of x from a known point. Oh, I better not call it x. I'm going to get confused. I'm going to call it t's. They're dummy variables. I'm going to integrate f prime of t dt. They could be x's, but I want to integrate from 7 because I know where that is to some value on my x line, and I'll call it x. So I don't want to use an x there and there. We will not mark it wrong when you do that. That's okay. Well, you shouldn't have the same variable here as here because it's confusing. And so then we'll integrate this side from what? 7 to x of e to the minus t squared dt. I'm going to tell you right now, you cannot integrate e to the t squared or e to the minus t squared. It's not possible. Not every function has an antiderivative. Every function has a derivative, but not the reverse. Okay, how do you do this one? What's the antiderivative of f prime? F of t. Evaluated at 7 and x. See why I didn't want to use x's there? It's confusing. Equals, guess what? I can't do this. I just leave it. Now, I still want to find f of x. And I can. I think we had some homework problems like this. Fundamental theorem of calculus says that's f of x minus f of 7 equals this integral, a definite integral. And it looks very strange. How do you solve for f of x, Stephen? Yep. So f of x is defined to be f of 7 plus this integral. Down, you mean? Yeah, hang on, let me finish writing this. There. because I was getting f prime. If I integrate f, that's big F. If I integrate f prime, that's little f. Is that okay? You just kind of have to get used to the symbols there. Now, do I know what f of 7 is? What's f of 7? It's 3. So f of x is equal to f of, 3. That's your starting value. You didn't start at the origin. Plus this. It's an accumulator. It accumulates the area under the curve. Let's check to see if we did this right. F of 7 is equal to 3 plus the integral from 7 to 7. What is that? What's the integral from 7 to 7? It's 0. And you were given the initial condition, f of 7 equals 3. Here, let's do one other one. What if I say f of 8 is equal to 3 plus the integral from 7 to 8 of e to the minus t squared dt? You could draw rectangles under that curve, find out that area, or you could use your calculator to find this area. That's a calculator problem. I can't find the antiderivative of that. It doesn't exist. There's no antiderivative for it. I can bring up my CAS calculator and show you.
No, we don't know you calculate.
You don't know how to use the CAS.
Oh, yeah. Come on.
Okay. You do not know your partner scores. So how about if I have you, the people who have not taken the partner test are excused. Who is that? That's Zach and Casey, right? They haven't taken the partner. Yeah. What? We'll work it out with Zach. Oh.
What's the 12?